Okay, so for this next example, for example number 3 on beam column, so as you can see from your screen, okay, so we have a 7-meter grade 60 W10 by 60 eccentrically loaded column as shown. So as you can see from the figure, you have a wide flange section. Okay? So again, yung L natin is 7 meters. Tapos yung grade 60, that means ito yung FY. FY means that is 60 KSI. So pagka walang binigay na FY in terms of megapascal, you will be using FY of 60 in terms of KSI. Okay, so 60 KSI. So if we want to convert it to megapascal, just multiply it with 6.9. And that is actually 414 megapascal. Okay, so this column section carries an eccentric load of 190 kilonewton here. So this is the P applied, 190 kilonewton, applied at a certain 180 millimeter from the x-axis and at a distance E from the y-axis. So as you can see, since the load is applied at a certain distance away from the x and away from the y-axis of the section, so it means that the section will experience axial compression and bending about x and bending about y. No? So tatlo ang may experience no member na to. So therefore, this would be a beam column. Beam column, axial compression, and bending about x tsaka bending about y. Okay, whereas to determine for the maximum distance E, if the ends of the columns are transition fixed and rotation free. So what does it mean? Translation fixed, hindi siya magmo-move laterally, yung joints, yung dulo-dulo, pero it is free to rotate. So that means the supports are hinge. So we have both ends are hinge. Okay? So we could look at this as this is the column, tapos hinge at both ends. Okay, so the length of which is 7 meters. Okay, the given load of 190 kilonewton is 40% live load and 40% dead load and 60% live load. Assume compact section and lateral supported all throughout its length. Cm is equal to 1.0. Okay, so if we solve for the load, for the P ultimate, that would be 1.2 of the dead load. Dead load is 40%. So 40% of the 190. Okay. Then plus 1.6 of the live load. Live load is 60% of the 190 kilonewton. So from there, I could solve for the P ultimate. Okay, P ultimate would be 273. Okay, 0.6 kilonewtons. Okay, so yan na yung ultimate. Now, so assume compact section and laterally supported all throughout its length. So anong implication nun? Okay, so since the section is compact as given and laterally supported, so that statement says that the nominal moment strength, Mn, X, is equal to plastic. And that would be Fy, Zx. Likewise, for moment about Y, Mny would be equal, since compact section siya, it would be Fy, Zy. So yan yung mga implication ng mga statements na yon. Tapos yung Cm value is also given. So hindi na tayo magsosolve ng Cm. 1.0. Okay, then the properties of the W10 by 60 sections are all given, such as the depth, the area, the inertia, the radius of gyration, hanggang sa plastic section modulus. Okay, so let's have its solution here. Okay, first question, are you convinced that this problem or this member is a beam column? Yes, no? So beam column 'yan kasi meron siyang axial, which is the P, and we have its moment about X at saka moment about Y because of the eccentricities. Again, due to the load P, may compression siya. Tapos due to the eccentricity about X and about Y, magkakaroon siya ng moment about X and Y. Okay. So the P sub U would be equal to, as calculated, 273.6 kilonewtons. Okay. How about what would be the maximum moment mu x? What would be our MUX, or the maximum moment about the x-axis? And that would be the PU multiplied by the eccentricity about x. And the eccentricity about x is 180, or that's 0.18 meters. Okay, so that would be 273 times 273.6 times 18, so that would be our MUX. 273.6 times 0.18. So that would be 49 to 400 to 48. So that is kilonewton meter. Okay, tapos yung MUY natin would be PU times yung E, which is unknown. And that would be 273.6 times E. And that is expressed also in kilonewton. Let's say E is expressed in meter, so that would be kilonewton meter also. Okay, so yun yung mga actual loads natin. Now, so pagka beam column, ang unang i-check natin is, i-check natin yung PU over phi PN if it is less than or equal to 0.2. So i-check natin siya. So okay na tayo sa PU. Ano yung phi PN? Ano yung phi PN? Okay, so of course yung phi natin, that is compression, that's 0.9. Okay, ano yung PN? PN is, di ba, FCR AG. Okay, ano yung FCR? FCR depends on the slenderness ratio of the column. So, unahin natin slenderness ratio, KL over R. Ano yung K? Both ends hinge. So, 1. Ang length natin is 7 meters. So, in millimeters, 7,000. Divided by R. Ano yung R? Wala namang lateral support dun sa member. So, yung R natin would be the R minimum. And the R minimum would be the RY. And the RY is 65.1. So, the slenderness ratio would be 107.52688. Ayan, so store mo na lang sa calculator. Then we compare it versus the C sub C. The C sub C is 4.7171 square root of E. Okay, yung E, anong gagamitin natin E? Yung 200,000 megapascal ba o yung 29,000 KSI? So since yung Fy natin is, ang given is yung grade 60 in KSI, so wag mo na i-convert yung 60 to MPa. Sa halip, ang gamitin mo na lang na elasticity, 29,000 KSI. So 29,000 KSI divided by 60 KSI. So cancel lang yan. So C sub C is ratio, and that gives us 103.54. 5486. So therefore we have since our KL over R 107 is greater than C sub C, therefore we have a long column. Okay, so we have a long column. Now, for long column, punta tayo dito. For long column, ano ang FCR natin pagka long column? Diba yun yung 0.877 FE. Now, ano yung FE? Yan yung Euler stress, which is pi square E over the KL over R square. So, pi square E, say 200,000 para maging megapascal yung Fe natin, divided by the KL over R, which is 107.52688. So our Fe is equal to 170.724 megapascals. So solving that FCR, so that would be 0.877 times Fe, 170.724. So our FCR becomes 149.725. So again, that is still in terms of megapascal. O, pag alam mo ni FCR, edi makukuha mo na yung VPN. So VPN is equal to 0.9. Ano yung PN? FCR AG. So that's 0.9. FCR is 149.725 times AG. AG is the section property from the given 11,400. So 11,400. So from there, makukuha mo yung VPN. 1536.192. Okay, so that is in kilonewtons na yan. So finally, with that VPN, so we could solve for the ratio. So therefore, the PU divided by the VPN equals 273.6 divided by 1536. So the ratio is 0.1781. 0.1781. And that is less than, diba? Less than 0.2. Therefore, ano yung tawag dyan? Pagka mas maliit sa 0.2, ibig sabihin, we have smaller axial compression. So, ano yung interaction equation that we have to use for smaller axial? Okay, so check. Let us check. Smaller axial, maliit ang axial. So, ibig sabihin, maliit yung axial, gagamitin mo yung 1/2. Yung may 1/2. PU over 2 of VN, di ba? Tapos plus MUX over VMNX plus MUY over VMNY should be less than or equal to 1. So let us check the adequacy by checking this interaction equation. Again, smaller axial, maliit ang axial, kaya 1/2 lang yung axial. Pagka larger axial, anong gagawin doon? Pagka larger axial, ibig sabihin malaki yung axial, maliit naman yung moment. So maliit yung moment, ang gagamitin mo doon yung 8/9 na interaction equation. Okay, so how do we check this interaction equation? So basically, yung mga numerators, alam na natin yan, no, na na-solve na natin siya doon sa pinakaunang part. Ito na yung mga numerators. So basically, yung denominators na lang yung mga hanapin natin. Okay. So yung first term, okay na tayo sa first term. Yung PU over PPN, i-divide na lang natin siya ng 2 mamaya. So okay na yan. So let's start with phi m and x. Okay. So yung phi natin is 0.9 for flexure. So alam natin yan. So paano natin makukuha yung m and x? M and x. Okay, since it is, 'di ba, sabi natin ang tawag dito, this is so considering yung amplification factor, so yung m and x natin, sorry, yung m and x natin would be fy zx lang. Kasi As given in the problem, the section is assumed to be compact tapos lateral supported siya within the span of the beam. Okay, so di bali, ang MNX natin would be equal to MP or MP is equal to FYZX. Sulat ko lang. So MNX is equal to MP which is equal to FYZX. FY 60 times ko ng 6.9 times ko ng ZX. Yung ZX is the section property. Okay, that is 112. 1222. So we have 1222 times 10 to the 3 millimeter cube. So sa calculator nyo, ang lalabas dyan would be Newton millimeter. Okay, so divide na lang natin siya ng 1 times 10 to the 6 para siya maging kilonewton meter. Okay, so that would give us 505. So this is 505.908. That's already kilonewton meter. Okay? Now, how about for MN Y? So, ganun din, no? So, phi niya is 0.9 flexure. So, ano yung MNY? Okay, yung MNY, since again, compact section siya, so that would be plastic din, MP. And that would be FY, ZY. FY 60 KSI, convert to megapascal, 6.9, times the ZY. And ZY, from the given property, is 574. 574 times 10 to the 3. That's Newton millimeter. Divide lang natin siya ng 1 times 10 to the 6 para maging kilonewton meter. Okay, so that would give us 237.636. Yan. Okay, so yan naman yung mga denominators. Now, so ang gagawin natin dito is applying. Let us apply moment amplification factor. Moment amplification factors. And these are the B1 of X and the B1 of Y. Okay. So, saan ba natin kailangan yung mga amplification factors na yan? So, para makuha natin yung bagong MUX. So, yung MUX na na-solve natin kanina dito sa taas, yung 49, wala pa to kasing amplification factor. So, ang bagong magiging MUX natin, let's say, would be equal to B1 times M, ang tawag natin doon yung MT, no translation NT. So di bali itong MUX na to, ito yung 49, yan yung MNT about X. Kasi ito naman sa taas, yung MUY natin na na-solve kanina without the amplification factor, ang tawag dyan is MNT about Y. Okay? So that would be B1 of X times MNT of X. Likewise, yung MUY natin, pag nilagyan natin ng amplification factor, that would be B1Y times the MNT out of Y. Okay, so yung mga MNT natin, yung mga moment natin without no or yung moment natin with no translation, ito yung mga values natin sa taas na nakuha. But again, wala pa kasi itong amplification factor, hindi pa nakako-consider yung P delta effect nito. So kaya we need to solve for the B1 and the B1X and the B1Y. Oops. Now, let us solve for B1. Okay, for B1, say X. Diba that is CM divided by 1 minus PU over PE. So kung X yan, so CMX yan, tas PX din yan. Okay. Yung CM natin, it was given in the problem, diba? Sinabi sa problem na ang CM is, ilan nga ba ulit? Ito, is equal to 1. Ito. Okay, so pagka CM is equal to 1 na sinabi sa problem, so ibig sabihin doon, it follows na it's both applicable for CMX at saka CMY. So that would be so 1, tapos 1 minus, okay, ano yung PU? Yung PU, yung na-solve natin kanina na 273, diba? So 273.6 kilonewtons divided by, ano yung PEX? PEX is the Euler's critical load. And that is pi square, okay? Pi square EI is 200,000. Anong I? Anong I yung gagamitin natin dito? Since this is for B1X, so dapat ang gagamitin mo rito should be the IX. Okay, so yung IX natin is 1222 times 10 to the 3. All over, again, PX, ano yung PE? Pi square EI over L square. L is the effective length, so 1.0 times the length is 7 meters. Effective length square. Ayan, so yan, di bali ang lalabas na B1 of X natin. Okay, so again, pagka B1 of X ang hanap, ang isa-substitute mo dun sa inertia should be IX. Okay, so pagka sinolve mo yung B1X na yan, actually that would give us a value of 1.05. Okay.
Sir, mali po ata yung value ng IX.
IX. Sorry, ZX pala yun. Sorry. So let me correct the IX. So the IX is 142 million. Thank you for that. So 142 times 10 to the 6. That is the IX. Now, anong unit nung PX natin dito sa ilalim? Okay. So ang lalabas kasi dyan sa ilalim is megapascal, tapos this is mm to the 4th, diba? Tapos this is mm square. So ang lalabas dito sa ilalim would be newtons. So to make it kilonewton, kasi kilonewton yung dito sa ibabaw. So ang gagawin natin dito is i-divide natin siya by 1 times 10 to the 3 para siya maging newtons din. Okay? Kaayusin ko lang. Ayan, so that would be our B1X. Okay? So this would give us 1.05023. 05023. So yan yung B1X natin. So medyo may may increase tayo ng 5%. 'Di ba? 1.05023, that means may increase tayo ng 5%. Medyo malaki na yan, no? Because of the P delta effect. Okay, so let's now have B1 about Y. B1 about Y. So that would be CMY. So given naman yan, 1.0 din. Pagka hindi given, you have to use yung 3 cases natin for the values of the CM. Yung may side sway, case 1. Yung case 2 is without side sway, without transverse load. Tapos yung case 3 natin is without side sway, tapos may transverse load. No? So yun yung pagkuha ng CM values natin. If ever it will not be given. Pero again, for this case, it's given. So gamitin lang natin kung ano yung given. So for B1Y, so that would be 1.0 yung CMY. So 1 minus, again, the PE is 273.6. Again, that is kilonewton divided by PEY. Okay, ang PEY naman would be pi square E, 200,000, times IY. O, tingnan natin yung IY. The IY is 48 million. IY is 48 million. 48 times 10 to the 6. Okay, divided by effective length square. Hinge 1.0, length 7 meters square. Okay, so again, since the PU is in terms of kilonewton, so divide natin siya ng 1,000 para siya maging kilonewton din yung nasa ilalim. Ayan, so that would give us B1Y equal to, ito medyo mas malaki ito. So 1.16. 16,482. So that means meron siyang 16% increase in moment due to P delta effect. So yan yung ibig sabihin niyan. Okay, so pagsasama-samahin na natin lahat sila. Okay, so let us substitute everything in the equation. Okay, substitute in the interaction equation. Okay. So yun yung PU over VPN, sulat ko lang, over 2 plus MNX, MUX over VMNX plus MUY over VMNY. Check natin kung adequate siya by checking if it is less than or equal to 1. Okay, yung first term, meron na tayong value ng PU over VPN. Diba? Yun yung 0.1781. Tapos di-divide na lang natin siya ng 2. So yan yung first term. Plus, yung MUX natin is B1, 1.05023 B1 times MNT. Ang MNT natin is, MNT natin is about X 49 to 48. 49.248. Okay, so divided by phi MNX. Yung phi MNX natin is phi is 0.9. Yung MNX natin is this, yung 505. Now 505. 505.908. So check natin yung units. Diba yung 49 is kilonewton meter na siya. Tapos yung 505 kilonewton meter din. So consistent na siya. So maka-cancel lang yan. So it would just give us the ratio. Okay, then the last term would be MUY. Yung MUY natin would be B1Y 1.16 482 times times yung NT natin, no? So dun sa MUY, yun yung 273.6 times E. So yung E yun yung unknown. So times E. Okay, so times E. Yan. Yan yung unknown. Divided by phi is 0.9 for flexure again times MNY. Yung MNY natin, na-solve natin to be 237.636. Ayan, so yung 273.6 is in kilonewton. Let us assume that yung E value natin is in meter. So kilonewton meter na yun nasa numerator dyan. Tapos yung 237 naman is also in kilonewton meter. So consistent na siya. So then, we're going to check and equate this with if it is less than or equal to 1.0. So since yung E yung sinosolve natin, so ang gagawin natin dyan is solve for E. Okay, so yun, pagka kinalculate natin yung E natin dyan, so E should be less than or equal to, ang lalabas dyan sa calculator natin is in meter, so lalabas is 0.535096 meter. So therefore, ang E maximum would be equal to 535.096 millimeters. So that would be our final answer. So ganyan kalayo dapat yung load from the y-axis so that the member would be adequate. Question about this problem? So again, this problem, we were able to analyze and solve for the maximum distance considering amplification factor. Okay, so ganyan yung mangyari. So kapag hindi sinabi sa problem kung gagamitan mo ba ng amplification factor o hindi, so pag walang sinabi, use amplification factor. Pero pagka sinabi sa problem na do not use, edi wala na tayong B1 tsaka B1 na isosolve. So just get the and just check it against the interaction equation lang. Wala na tayong amplification factor pag sinabing do not consider the effect of P delta moments. So yun. Okay, pero pag walang sinabi again sa problem, use amplification factor as part of your solution.